Hey everyone, in our last video we learned how to install Sippy on a CentOS machine. So as we discussed, right, a Sippy server, you can install it on a CentOS, Linux or any other flavor of Linux versions probably, and also you can install it on Windows machine by installing Cygwin on Windows, and on top of Cygwin install Sippy server. So we also learned like Sippy server, it can be used as a a client and a server model, wherein you can initiate a good amount of calls to do the load testing and check the performance of any of the server, right? It can be used to also test many parameters that you wish to do. Now in this video we will do some demonstration like how do we use Sippy server. Now here in our call flow scenario, right, so this is the server. What you see here, this is the server which we installed in the last video as a Sippy server on a CentOS machine. Now here we have a call manager installed already, and this call manager is basically having an IP address 172.160.160, and there is a SIPp phone registered to this call manager which is 10,002, and this phone is a micro SIPp phone which is installed on my Windows server, and this is registered to the call manager. Now this call manager is also integrated with Unity connection, Cisco Unity connection, with the IP address of 172.168.0.161. Now why are we using Unity connection is I'm going to tell you about it in a bit. And this Unity connection also have a call handler configured with an IVR as 10,049. So which means like if you dial 10,049, you are going to reach to an IVR server. So the reason why we integrated Unity connection here is, so let's say if we have to generate 10 calls per second, right? So when the client makes a call, right, your Microsoft servers can or Microsoft phone can handle only one call at any point of time, right? So all the 10 calls you cannot handle simultaneously on this one SIP phone. So what I've done is like I've created a small IVR on the Unity connection with 10,049 number, so with 10 ports, so which means like this Unity connection can handle 10 calls at any given point of time, and any calls beyond 10 the Unity connection will not accept those, but at least 10 calls will be active at any point of time. So this will clearly do a load testing on the on the call manager and the Unity connection as well, right? So what we'll do is we will go through some of the articles here. So here this is what you're looking at is sippy.readthedocs.io. so we have installed like 3.7.0 version, but however the documentation is almost same for all, right? So here it talks about like how do you install and what are the parameters that you need to use, features, etc. There are a lot of things that it talks about. And there's another documentation which you can use as a reference, sippy.sourceforge.net/doc/reference.html. so here you can look into this documentation for your reference, so where you learn to know like what is the usage of any command that you wish to, and how do you actually make calls and whatnot. So it is clearly a good documentation how to start with the Sippy server software. And if I have to show you the usage, so usage is somewhere here in between. Let me show you. Let me go down. Yeah, so if you look here, so this is the usage here. So once you enter the command /sippy, so you might have to put sn. So sn is used for what? So if you look sn is a default scenario embedded in the Sippy executable. If in case if you want to use sf, so what sf means, like you are going to load an XML file in order to make calls. If in case you want to use some other parameter, for example, let's say -i. So here -i, you are going to set the local IP address of while making the call, right? And if you want to use a different version, for example, let's say uh, uh, -r. So -r means you are going to set the rate. So when I say rate, I'm talking about call rate per second. So in per second, how many calls you want to make. So this is something you can control, plus minus into divide. So this all it talks about if you want to increase, decrease, or increase by 10 times or decrease by 10 times. So this is something what you can play around with. Then you can play around with a rate limit. Then you want, if you want to stop the calls at any point of time, right, you can use -i, -m. And then there are a lot of other things which I'm yet to explore many of these things, but yeah, this is a common usage that you have to use when you're making a call. So this is one of the usage example. /Sippy -sn uac. You are saying like to execute this command as a client. So there are two models, right? One is uac, c is client, and suas, which is server. So, and this is going to be the IP address of your Sippy server. So let's get started. So before we start, right, so I wanted to show you how exactly the commands are going to look like. So let's do a SSH to Sippy server. So let me open putty and do SSH. So this is putty. I'm going to put 172.160.99. This is the IP address that we set, and enter the username and the password. Okay, so I'm logged into the Sippy server as a CLI. So now I'll do a cd Sippy 3.7.0 folder, and now I'm into this folder right now. Now, if you want to make some calls, you have to enter some commands. So these commands are like which we have seen here. So let's give it a try. We'll enter this command /cpp and then -sn. So sn is used for the default scenario, which is mentioned here, and then we'll enter as uac client, small client model, and then 172.168.0.99. So that's going to be our Sippy server. And then what we can do is we can hit enter. So which means like this particular client is trying to send make initiate calls, but however, like there is no destination or anything we have defined, right? So if you make this for the testing purpose, right, what I'm going to show you is I'm going to open another session. So here what I'm going to do is -sn, then US, sorry, yeah. So now this, if you look at here, right, so on the right hand side, this is acting as a server and this will act as a client. Now whatever calls I'm going to make, so this server will accept those calls. So you see, so 20, 30 message, 43 message, so all of these messages are being sent from this client, and the same server is acting as a server. So this is just for testing purpose, what I'm showing you here right now. So I'll stop this for now. So now what I wanted to show you is actually by doing a simulation with the real-time use case, right? So when I say real-time, so I'm going to make a call as per this scenario. From the SIPP server, I'm going to make a call to this micro SIP phone, and this SIP phone will get a call, and once this SIP phone will get a call, this SIP phone will answer, and back to back this SIP phone will continuously get calls, right? So let's see this scenario first. So I'll exit from the server side. Now let's continue with the client model itself. Before that, right, I have to define some XML parameters on this particular server. So when I say XML parameters, so I'll go to this particular scenario here. So click on the UAC and UAC with media, any one of this. So once you click on this, So there are two files, uac.xml and uac_pcap.xml. So what exactly it does? So the one which is uac.xml, right? So this Sippy uac, so which is nothing but this Sippy uac is going to this and this remote is nothing, it's going to be here. So basically the call manager and the SIP phone. So it is going to send an invite, and then the remote server is going to send a 100 or 180 ringing, and then 200 okay, and then acknowledgement, and then your basically RTP stream is supposed to establish, right? But it'll disconnect the call immediately because we are not allowing the call to establish an RTP stream. So as soon as the call is answered, it disconnects the call. And then after this, the client is going to send a pie as soon as the call is answered, and we are going to receive a 200 okay. This is going to continue till the time or whatever parameters you define. So let's say you define a parameter where you say like, okay, I'm going to make 10 calls per second. So every 10 call per second will continue, it'll send 10 invites at the same time for this 10 calls. Let's say you define a parameter like I want to send like one call, and after first call is disconnected, I want to send the second call after 5 seconds. So when the first call is being sent, this particular parameter will be passed, and it'll take a cap of 5 seconds and it'll send another invite. So this is how exactly it is going to work. Now what is UAC with media? So here in the above scenario, when the RTP stream, when the call is connected, it disconnects, it sends a goodbye message immediately. But with UAC with media, what it is going to do is it is going to make a call to the SIP phone. SIP phone is going to basically there is 100 or 180 ringing coming, 200 okay coming, and acknowledgement is sent. Now after the acknowledgement is sent, then then this particular UAC server or UAC client will send a RTP stream where it is going to play some message to the remote party. So when it plays this is where exactly this is going to happen. So this is where the RTP stream is established, and RTP will be sent to the remote phone for 8 seconds. So after this 8 seconds, this client, UAC client, is going to send a DTMF digit 1 to the phone, and then as soon as this DTMF digit is being sent, it sends a goodbye message, and after this goodbye, 200 okay is received. So here you are basically playing a media. In the above scenario, you are not playing a media. So this is the difference between this two XML. Of course, there are configuration wise also there are different between this XML file. So we'll go through this how exactly it look like. So what I'm going to do is I'm going to download this uac.xml and uacpcap.xml, and what I'm also going to do is I'm going to use FileZilla and SSH or do a SFTP to this particular server using FileZilla. So let's first do a SFTP to this particular server using FileZilla, and then we'll copy these two files which I was talking about, uac.xml and uacpcap.xml. So let's do a SFTP. So I've opened FileZilla right now. So I'm going to put the IP address of the server 0.99, and now I'm going to put the password and the port number 22. Connect. So I'm basically connected to this particular server. So I'll go to this Sippy folder. Now in this Sippy folder, I'm going to download these two files and copy these files in this server. So let's download this file. So I'll save this link, UAC. Okay, these two files are downloaded. So what I'm going to do is I'm going to copy these two files into this directory here. Just give me a second. Okay, so these are two files. So I'm going to copy these two files, drag it here. Now these two files are copied. I'll close this session. So if you look here, these two files are copied. Now what I'll do is I'll quickly show you how does the uac.xml looks like. Let me do one thing. Let me open this in Notepad. Now this is how it works. Like it basically sends an XML, right? So this is the XML file looks like, where it is going to send the data from here, basic SIPp on UAC. Invite, it is going to send an invite service. So this service talks about like the number, okay, and this talks about the remote IP address, this talk about remote port. If in case if you want to understand what exactly this service means, right, you can always copy this and go to this documentation, and if you look here, services minus S stands for service. So let me show you that. Service field as a password in the minus S service name. So minus S stands for your service. Now there is another thing called remote port. Let's see what exactly the remote port means, right? You can again copy this. Remote port, remote IP address is passed on the command line, and then remote port, remote IP port is passed on the command line, right? And then let's see what exactly this transport means. So it says like whether you want to set the parameter as transport type as UDP or TCP. So by default it uses UDP. Then local IP address, so it says what is the primary host IP address of your server, who is going to initiate this call, and port number, etc, etc, and call ID. It is going to take default by itself. And if I go down, so here there's something called media port. So media port, what it says, depending on the value of MP parameter, it set the local RTP echo port number. Default is none. RTP UDP packets received on this port are echoed to the sender. You can add a computed offset media port +3 to this value. You can play around with this parameter if you wish to, but you can leave it as default so that the default RTP port number can be taken. And so first invite is being sent, right? So this is what invite is being sent, and then this is optional, as it was mentioned in the documentation. Optional equal to true, receive a response of 100 or 180. So you may get a response back from the other end, or maybe 183. So you may or you may not get, right? And on top of this, so receive a response is 200 is true, so you need to have a response of 200. Now after this, there is an acknowledgement being sent. So this acknowledgement is basically sent from the server, and after this acknowledgement basically is when your RTP stream is established. Now let's say if you want to establish a RTP stream, let's say you want to keep the call open for, let's say, 10 seconds. You want to after the call is answered, you don't want to disconnect the call immediately. You want to hold the call for 10 seconds, right? You can add you can play around with the pause parameter here. So you have to play with this, like you have to say, okay, I'm going to hold this call for this many seconds, and after this call is hold for this many seconds, I'm going to send it by, and then the next call will be established, or next call will be initiated, right? After when the next call is initiated, basically you are again sending a goodbye to the other end, and again receive a response of 200, okay, 200, and then this is how your call is basically established end to end, right? So this is how the XML looks like, and you can play around with this XML if you are confident enough. Now what we'll do is we'll not change any of this parameter for now. We'll leave it as it is, and now what we'll do is we will basically try to make a call and see how the calls are going through. Okay, so let's open the command line here. Now what I'll do is I'll enter the command SIPp -sf. So sf stands for let's see there, what was the command? Sf. So sf loads an alternative XML file. So we are loading a XML file. Sf then will load as uac.xml. So this uac XML is basically this file what we are loading right now. So uac.xml, and then you have to define the IP address of your call manager, 160, and then the port number of your call manager, right? And then -s. So -s is nothing but -s stands for where's the command here? just let me search. So minus s is for set the username part of the request. Default is service. So what we are passing in at this moment, and we'll say 10,002. So this 10,002 is nothing but this particular phone number which is registered to the call manager, and then we'll define the IP address of the client server itself, 0.99, which is the UAC server itself, and then we'll pass a value m. So this m stands for your limiting the call. So let me show you that, minus m. Yeah, stop the test and exit when the calls are processed. So we are going to exit the call after the first call, so which means it is going to send one call, and after that it is going to stop the test, right? So let's see that. Okay, so looks like I have messed up with some parameter. Let me see that what exactly I did mess it up. Okay, I think I forgot minus I. So here minus I, if you look here, minus I stands for set the local IP address for contact via and from headers. So this is what I missed. Now let's try again. Okay, so if you look here, I made the call. Looks like the invite was sent for the first call, but however we did not receive any 180 ringing or 183 session in progress from the call manager. So if you look, when we made the call, the invite was sent, but and then 100 trying was received, but 180 ringing or 183 session in progress was not received, and hence the call was never established. So which means like there was, out of one call, outgoing calls, whatever one calls we made, and there was one failed call. Now the reason why this call was not successful is, one of the reason is because we have not created a SIPp trunk between the call manager and the Sippy server. So if I talk to you about it, so there should be a SIPp trunk between these two servers. So one is Sippy server and one is between the call manager. So let's set up a SIPp trunk between these two servers so that they can accept the call. So now if you also look at the message here, aborting call on an expected message call ID while expecting 180. So it was expecting a 180, but it received service unavailable or instead, right? And this is why the call is failed. Now there was another warning message. If you look, warning 399, CUCM unable to find device handler for this request received on port number 5060 from 172.160.99. So let's create a SIPp trunk, and then after that we should be able to go. Let me go to the call manager and create a SIPp trunk. Okay, I'm in the call manager right now. I'll create a SIPp trunk. Click on next. I'll mention it as maybe UCC Sippy. Okay, give a description if you want. Device pool, I'll leave it as Bangalore DP, and rest of the parameters I'm not going to touch at this moment, and run on all active nodes. Doesn't matter, we have only one node. And if I go down for the inbound CSS, I'm going to select internal CSS, because when a call is being made by the Sippy server, the call will go by this trunk, and when the call goes to this micro SIP phone, this SIP phone is in internal partition. So I want to make sure this trunk has access to this phone partition. So this phone is in internal partition, so I'm assigning internal CSS to this trunk so that this trunk can call up this phone, right? So I'm assigning this internal CSS. Now I go down here, I need to define the IP address of your destination, 172.160.99, and the port number is going to remain as same. So this is for your outbound calls from your CUCM to Sippy server. So destination is going to be 5060. SIP trunk security profile, I am going to use as default. SIP profile, I'm going to use as default, whatever is there. Save. Reset this trunk. Okay, so the trunk is reset now. So what I'll do is I'll reset terminal, clear scroll back, and now make another call. So you see, I'm getting a call on my phone. I answer this. So if you notice here, as soon as I answered the call was disconnected. So basically, which means the call was answered and it disconnected. So which means it sent this particular Sippy server sent a goodbye message to the call manager and it hanged up the call. It did not hold the RTP stream. So now, if I have to show you this, let me expand this a little bit. Or let me also do one thing. Let me increase the font size. I'm not sure if this is visible to you. So let me do one thing. Let me go to this change setting and then appearance change. Let's make it 80. Apply. Let's make another call, and I think this should be visible pretty much now. Okay. Yeah, so the call got disconnected. So I enter this command. Okay, after this command, it says resolving remote host 172.160.168. It did a resolution, but it didn't require a resolution because I have put the IP address instead of host name, right? And now it says you some of the information in the dashboard. Call rate 10 is what one call 1 per second, and port number, total time it has taken 1.89 second, total calls 1, remote host, this is the call manager IP address what is given. Now call rate, it gives you other parameters, right? So this is some of the information which will be easy for you or helpful for you if you are looking for some detailed information. Now at the first stage, this client sent an invite to the call manager. Then call manager sent a 100 trying. Call manager then sent a 180 ringing. And if you look at 183 session in progress, the value is 0. So this means we did not get a 183 session in progress. And then we received a 200 OK from the call manager, and then we sent an acknowledgement back to the call manager, right? And this is where your RTP is established, right? This is the place after the 200 OK is where your RTP is established. And then there was a pause for 0 second. So which means it did not hold the call. When the call was answered, it disconnected the call immediately by sending a bye message. So bye was sent from our end, and we received a 200 OK for that, right? Now, if you look at the statistics, it says this is the time we started, okay, and this is the last reset time. This is the current time on the system, and it says you some periodic and cumulative value. So if I have to show you some of the other important information, so incoming calls 0, outgoing calls we did 1, and total number of calls created 1 because we made only 1 call. Current call, there is no current call at this moment, so it says 0. Successful call is 1 in the cumulative value, and failed call is going to be 0 because there was no failed call. So this is how the test looks like. Now let's say if I have to show you like instead of 1, let's say I make it as 10, right? So let me reset the terminal better so that you'll see a fresh screen again. Instead of 1, I'm going to make it as 10. See, what it did was it made 10 calls, okay? But as this soft phone is able to only receive 1 calls at any point of time, right? So remaining 9 calls were not being received. So it sent 10 invite to the call manager. Call manager sent 10 100 trying, 10 180 ringing, and 200 OK 10, and acknowledgement is 10 again, pause is 10, buy is 10, and this 200 is 10. Right now, if you look, total number of successful calls were 10, but however we received only, or we answered only 1 call in our system, right? So this is what it talks about. like all the 10 calls were successful though, but however we received only one call because when I was talking on the call at the same time, the call has went to the voicemail because I was talking on the phone, and the call went. So to give an example here, right? So first call came here, I answered the call here on this phone, and remaining calls went to the voicemail because at that particular point of time I was talking on the phone, and hence the reason rest of the calls went to the voicemail, and hence it says like those were successful calls. Now let's say if I make it as offline. Now let's see what happens to the statistics at that time. So I'll make this as 10. So I'll not receive any calls, but all the calls will be answered by the Unity connection because Unity connection might have got 10 calls as part of the voicemail. And that's the reason it says as successful calls. But let's say if I turn off the Unity connection for some reason, or let's say the Unity connection is not there, or I disable the voicemail, at that particular point of time, it'll be a failed calls. Okay, so now what we'll do is we'll play around with the pause in between. So which means like we'll play around this pause part, right? We'll add some logic here so that the call is not disconnected immediately. So what I'll do is I'll modify this pause file here. Let me go here, and what I will do is I will add some data here in this pause. Okay, let me modify this pause milliseconds equal to, let's say 5000. So we'll put it for 5 seconds, and then after this 5 seconds let's hang up the call. I'll save this parameter here, close, save those changes, the files are uploaded. Now let's do one thing, let's reset the terminal here. Now instead of 10 I'm going to make one call again. Let's see how it works. Oops, I did not basically I did not have this phone registered, I guess, so that is the reason it didn't get the call. Let's do one thing, let's reset it again. Okay, I'm getting a call, answer the call. Oops, looks like the call was disconnected immediately. So there is something wrong I have done with the file. Let's see what's wrong with the file I have done. Go to this particular file, edit, go to the pause area where I have set the pause. Okay, I think I need to remove the space, save the file again. Let's see if it works now. Okay, so I'm going to make another call and let's see if it works this time. Nope, it didn't work. So looks like the call was disconnected immediately again. Let's see what I'm doing wrong here again. Let me check the syntax in the Sippy parameters and see. Okay, so let's open this. I'll search for pause. So this is the command that I was looking at. Pause milliseconds 5000. Let's see if we have put it in a wrong way. Okay, so it's here. Let's see what is the difference between our these two files. Okay, so it was a typo, I guess. I entered this as MILI, so instead of MILLI, so because of which it didn't work. Now save this value here, save. Now let's make a call again. Let's see what happens this time. Okay, so the call should last for 5 seconds and then disconnect. Okay, so we see invite, 100 trying, 180 ringing, 200 okay, acknowledgement. And after acknowledgement, if you see, this is where the call was lasted for 5 seconds. So there was a pause for 5 seconds and then it sent a buy, and then it sends we receive a 200 okay, 200 from the call manager. So this is how you can apply pause in between. But if you notice, right, when this call was made or received, we applied a pause, but there was no audio heard when this pause was applied. So it was a blank audio completely, so you didn't hear anything. If in case if you have not noticed, I'll show you again. I hope you can hear, right? There's no audio, right? And the call was disconnected. Now let's say you want to play some media in between. So what you can do is you can play around with the media. So how to play around with the media is, so you have to play with this particular file uccollabing.xml. So let's see how exactly this file is different from this file. So initially it is going to be the same file except some of the parameter. So if I have to talk about the parameters, so after acknowledgement, right, so here it is playing a pcap file. So basically what it does is it goes to this particular folder which is going to be pcap, and it is going to fetch this file g711e g711a pcap. It is going to play this file, and this file is around 8 seconds duration, and where it is taking a pause for around 8 seconds, and after this takes a pause, right? So we are basically playing a DTMF digit, so DTMF 2833_1. So if you look, this is playing this file, so which is a DTMF digit. So it is sending a DTMF digit 1 key, and then it is taking a pause for 1 second, and then it is going to send a buy. So this is how exactly the file is different from UAC file is different from UAC_pcap file. So let's try this UAC_pcap and see how to make it work. What audio we hear. Pcap. I will do the same thing and hit enter. Okay, so now when I am playing this particular running this particular parameter, right, UAC_pcap, I'm getting an error like auto_media port is not supported, or is the keyword is not supported. So let's do one thing. Let's modify this file UAC_pcap. So what I'll do is I'll open this file, and here I'll remove auto_ in the m equal to audio. I'll remove this auto_ and save this file. Okay, now reset this terminal again. Okay, so let's make a call. I'm getting a call.
No, prima di questo incazzare fai retimo cliccare samega serve.
So I hope you were able to hear this audio message, right? So there was something played, and after this 8 second of audio message, it disconnected the call. Now if I have to talk to you about the ladder, right, so this is how the ladder looks like. Invite sent from this UAC client, 100 received, 180 received, and then 200 okay received, acknowledgement sent. And after that, if you notice here, this is where the 8 second pause was applied, and we heard a audio message. And when the audio message was played, we played another DTMF tune when the call was after this 8 seconds of audio message, we sent a DTMF tune of keypad 1, and then we sent a buy, and 200 okay was received. So this is how exactly it looked like, right? So in case if you have not noticed, I'll play again once so that you can see how the audio message looks like. Okay, ringing.
No, prima di le questo incazzare fai retimo cliccare samega serve.
right? So this is how the audio message is being heard. So you can play around more with this, and you can make n number of calls. So right now I have tried with only one number, limiting to my phone. I can send as many as I can, or as many as I want, I would say, right? So now let's do a load testing and see how the call manager behaves on the load testing. So what I will do is I'll log into the RTMT tool, and after logging into the RTMT tool on the Unity connection and the call manager, I'll show you the load on the call manager and Unity connection. Let me log in. So here I'll enter the call manager IP address 160.160. Okay, I'll log into the Unity connection as well. 172.160.161. Okay, so the call manager RTMT is open right now. Let's go to the system summary and let's see some load here. So the CPU right now, I think the CPU usage is showing as 52. So it should not be that much, but this is my lab, right? So lab is having a limited resources, so it's up to 52 right now. So let's open the Unity connection as well. So what I'll do is I'll pause this till the Unity connection RTMT is getting opened. Okay, the Unity connection RTMT is opened. So what I'll do is I'll go to the port monitoring here in case of Unity connection. Select the node. Set the polling rate as 1 second and start polling. Okay, so right now if you see here, we are going to use this UCC phone system. So we have close to 10 ports in the UCC phone system. So let me show you how exactly it's going to look like. So here I'm going to make this as 10,049. So what exactly I've done in the call manager, I'll show you. So log into the call manager. Okay, I'll enter this 10,049. So this 10,049 is basically pointing to Unity connection SIPP trunk. So I'm basically, when you dial 10,049 from your system directly, for example, if I dial from the SIP phone, the call will go and connect to the Unity connection system.
Unity connection messaging system. From a touch tone.
Right. So we are hearing a Unity connection messaging system greetings from Unity. Right. So what I'm doing here is I'm going to say, okay, this particular UCP makes a call to 10,049. So which 10,049 is nothing but the trigger on the Unity connection system. So we have created a route point which will send the call to the Unity connection. So let's do that. Okay, we see there is one call. So let's see here. So this is the call which is currently there, and we are getting a greetings played from the Unity connection. Now this is about one call. Now let's see if I have to send many calls, then we'll see like the Unity connection will handle those many calls whatever we send to the Unity connection from the call manager. I see the load has load is around 76%, and the reason being because of my resources not being properly aligned on my system. So that's the reason it is at 76%, but ideally it should have been somewhere around 5 or 10% or 15 to 20% max to max. Okay, so it has come down to 21% right now if you look here, right? So this is how exactly, or this is how it should have been. So now since the CPU usage has come down to 21%, so I'm going to send a good amount of calls back to the Unity connection from the call manager and see how the load looks like. So what I'm going to do is I'm going to run a different command. So the command is not very much different, but it is going to be something like this. So instead of 1, I will make this as, let's say, let me think. I'll make it as -r, which is for rate, 10 calls per second, something like that, or maybe let's say 2 calls per second, or maybe I can send 5 calls per second, something like that, and see. Okay, so it is sending 5 calls per second. Let's see what happens. So all the ports should have been fully utilized by now. So you see there are so many calls happening, and if I have to show you the number of calls here, okay, so you see it is getting a lot of messages back on the back end because it is not able to tackle this many calls. But if you look at the let me see why the statistics is not being shown correctly. Hold on, what I'll do is I'll initiate the call again. 10,049. I'll make this as 5, or yeah, I'll make this as 5. Let's see again. Yeah, so now if you see, it is able to handle this many calls. Let's see the Unity connection. So in Unity connection, we are seeing all these ports are getting busy or getting fully utilized, and we are also seeing like we have sent around 85 or 90 messages so far, and out of these 90 messages, I don't think so this message is being played properly. I believe the Unity connection or the call manager is not responding to this. Let me stop these messages. So it says service unavailable. Looks like the call manager's service has gone down, because of which it is not able to handle those calls. Let me refresh this page and see what happens. And also let me open this RTMD. In RTMD it says the CPU utilization is around 28%, but it doesn't look like it's in real time. Looks like the services is crashed. So what I'll do is I'll wait for some time for this CPU utilization to be settled down, and then I'll resume this video again and we'll test the load shedding. But again, as I mentioned, like this is my lab, right? So my lab does not have full resources, and hence the reason you might see this call manager page going down. So let's pause the video for now, and then we'll restart it when the load has come down, right? Okay, so looks like my Unity connection load has come down to 15% right now. And let's see if on the Unity connection there are no active calls. So let me limit the load to 1 call per second, and let's see what happens now. All right. Okay, so the calls are being sent to the Unity connection from the call manager, and you see all the ports are getting fully utilized, right? And let's see how the load looks like on the call manager side. So the call manager load has increased from 15 to 24%. Again, it has gone down to 17%. So let's give it around like a couple of minutes and see what happens. Or maybe the number of calls we are sending is quite less. So let's see if we have to increase the number of calls by any chance. Okay, so if you look here, the load has increased to 30% right now. So likewise, the load is going to increase every second or every minute as soon as we make more and more number of calls. And I'm sure by now Unity connection, most of the ports are getting utilized, right? So all the ports are utilized, looks like. Let's see if our call manager page is responding or not. Let's try to refresh this page and see how the load looks like. So the call manager page is still responsive, so which means like the load is definitely going up, but the page is responsive right now. So what I'll do is I'll stop this for now, and what I'm going to do is let's give a minute time or 30 seconds time so that all these calls are freed up, and I'll send like 15 or 20 calls so that my call manager crashes, just to test it out in the lab. Okay, so let's give a minute time for the calls to clear up. Okay, so the Unity connection calls are cleared, no more active calls. And if you look, the call has whatever calls we made, it has went to around like 40% close to, and after 40% it has come down to 20%. Now what I'll do is I'll increase the load. Let's reset this terminal and increase the load to 10 calls per second. Now I'm sure the call manager is going to behave weird. See, so all the ports are fully utilized right now, and there will be many calls hanging in the queue, and call manager will slowly and gradually not be able to take those many calls. Let's see. So the load has reached to 18%. I'm sure it is going to shoot up. So let's give it a minute time. Okay, so if you look now, the load has increased to 55%. So I'm sure it might shoot up further than 55% as well. And let's see the Unity connection. So all the ports are fully utilized right now on the Unity connection. And if we keep more time, I believe it is going to shoot up more than 55%. Let's see. Okay, so it has come to around 41% now. So let's see if the call manager page is still responsive. Okay, the page is still responsive. So what I'll do is I'll stop this test again. Now what I'm going to do is I'm going to apply parse this different XML file, just the UAC XML file, not the PCAP one. So we are not going to send any media, but we are going to take a pause for every call. And now what I'm going to do is I'm going to make it as like 20 calls per second. Let's see what happens now. Okay, so far we have sent like 120 calls, 140 calls, 160, 180, 200. So this is the load right now we are sending to the call manager. Let's see now. So all the ports are fully utilized. Let's see the load. So load is still 38%, and the number of invites we have sent is around 600 or 721, 41, 61. Let's give a minute time so that the load spikes up. Okay, so let's see if the call manager page is responsive. So the call manager page is loading, so it is not responding properly. I would say like the Tomcat might have been crashed by now. And if you look at the ports, all the ports are fully utilized, and the call manager page is still not responding. Let's see. Okay, if you notice here, the Cisco RTMT, okay, it is stopped showing the data, so that means that definitely Tomcat has crashed so far, and the load has become very huge. Now if I have to show you the statistics here, right, so I'll stop this for now. So if I have to show you statistics, so we have sent like 3,302 invites to the call manager. We have received 3,333 100 try from the call manager. So there was a 82 retransmission and 50 retransmission here in case of 100 trying, and then we received 180 ringing for 208 messages only. So for the remaining 3000 whatever numbers, right, 3100 150, we have not received any 180 ringing or anything further that like 200 okay, pause, by 200, right? So this is we have not received from the call manager end. So looks like the call manager is not able to process those calls. So call manager was only able to process 209 calls so far. That's what it looks like. And if I go down further to the statistics, so outgoing calls created is periodic is 16 and cumulative is 3302, and total concurrent calls at any point of time was 10. The concurrent calls was 10, and total number of calls that we created was 3302, and 200 were successful calls, and 3092 were the cumulative field calls, and 16 was the periodic value of the field calls. And this is the call length, what it shows. And at last it has also shown you like it is receiving some messages like aborting call unexpected message for the call ID, where it has received like 503 service unavailable from the call manager. So while it was expecting for 180 ringing, but it has received 503 service unavailable from the call manager, and hence the calls were not getting processed from the call manager, right? And if you still notice, like the call manager, the memory was spiked. If you look at this particular portion, right, the memory was spiked to somewhere around 100%, and post that the RDMT is not responsive. So this is how basically you can do the load testing, and you can play around with it. I'm sure you will have more insights to it, and you will, while you are exploring this more, right, you'll have more feedbacks on this. Even I'm also exploring. I'm not an expert, as I said, so I'm still exploring this particular feature, and I will bring down whatever I know. So I'll bring down to the table whatever I know. So next thing what I'm going to try is, I'm not sure this is possible or not, but the next thing what I want to try is, let's say I want to automate some calls from Sippy on everyday basis. Now if in case if those set of calls, any of these calls fails, right, I should report a mail, or I should report some information wherein I should learn, okay, this particular number call is failed on so and so day and so time, so that the support team can check what happened to that particular trunk, or the link, or the even T1, why the call has failed, right? So this is going to be helpful in case if, let's say, if you have a contact center environment, or a very important customer who wants to monitor some sort of a traffic for the calls. There are plenty of tools available on the paid version, but I am looking something as a free version, wherein I can make calls to those set of numbers to ensure like the even T1 links are up, or maybe those numbers are up and responsive. If in case if they are not up and responsive, we can proactively raise a case with the service provider, or look into what is happening with those calls, right, and troubleshoot the issue before the customer report it back to us. So as I said, like, I'm not sure this is possible, but again, I'm going to give it a try and come up with a solution if this is possible or not, and demonstrate in the upcoming video. All right, I hope you like this video. Keep exploring, do share your feedbacks, and let me know how you like, if you like this tool or not. All right, thank you for watching.